The last video on 7.5 is objective 4, and it's a nice short one. It's just writing radical quotients in lowest terms. So what this is that it's an expression that has a radical in it, and it's also a division. And you'll notice that technically this first one is simplified in terms of its radicals, and yet you can simplify. So what I mean by that is there's a number that goes into 24, 36, and 16. To see that, you have two options. In chapter 4, we would have taken each term in the numerator and divided it by 16. In chapter 5, we would have looked for some greatest common factors, and that's the way that I sort of prefer to do it. So you're looking for a number that divides evenly into 24, 36, and 16. So that happens to be 4. So if I divide 24 by 4, I'm left with 6. If I divide 36 by 4, I'm left with 9, root 7. And then 4 goes into 16 4 times. So that I can simplify the 4's, and I'm left with 6 minus 9 root 7 all over 4. Alternatively, if you did write this as 24 over 16 minus 36 root 7 over 16, and you simplified this way, you'd think that 8 goes into 24 and 16, so this would give you 3 halves. And then 4 goes into both 36 and 16, so you'd be left with 9 root 7 over 4. And, some might argue that that's a good answer, and I agree. And again, it's one of those like, do I want it as a monomial or do I want it as a binomial? The answers in the textbook will give you a clue as to what they are expecting. Moving on to the next one. When I look at this one, I can't simplify the 2x and the 6x because I have to see if there's something that come out of the second term as well. In order to determine that, I look at this and I'm like, oh, I just want to simplify it. So we're going to simplify the radical first. So you've got 2x, and then I'm going to split that radical up into 2. Now, saying that, what you could do actually is simplify the radical on the side. So I'm going to do that. So what I mean by that is instead of having to do the work within my fraction and then write line, 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 I'm going to simplify my radical over here. So I'm going to have 2 radicals. The highest perfect square that goes into 32 is 16 with 2 remaining. And then x squared is a perfect square. So that's going to simplify to 4x root 2. And that's what I'm going to write in here. So I'm going to give myself a little bit more room. And I'm going to put in 4x root 2. Then I'm going to look at these 3 terms and look to see if they have any common factors. And in fact, I notice that I can take a 2x out of everything. I'm going to be left with 1 plus 2 root 2 all over 6x. Well, actually, and then let's write that as 2x times 3. Just so that everything's fully factored. Now that it's factored, I am allowed to simplify. And so I'm going to simplify the 2x divided by 2x is 1. And I am left with 1 plus 2 root 2 all over 3. And again, this is what the textbook wants, is the monomial. If you had done it, right here, you had split this into 2 terms, you would have had different denominators, potentially, and then you just have to put them together. Actually, I think this one would end up the same. We do 2x divided by 6x plus 4x root 2 divided by 6x. And I simplified here. So 2 goes into 6 3 times. X divided by x is 1, so this is a third. Plus 2 goes into 4 twice and into 6 3 times. X divided by x is 1. 2 root 2 over 3. Yeah, and so there you have a common denominator of 3, and you can write it as 1 plus 2 root 2. All right, go and give those questions for the last section of 7.5 a go.